A raised beach, marine terrace, or perched coastline is an emergent coastal landform. Raised beaches and marine terraces are beaches or wave-cut platforms raised above the shoreline by a relative fall in the sea level. Around the world, a combination of tectonic coastal uplift and quaternary sea level fluctuations has resulted in the formation of marine terrace sequences, most of which were formed during separate interglacial hailstones that can be correlated to marine oxygen isotopic stages. A marine terrace commonly retains a shoreline angle or inner edge, the slope inflection between the marine abrasion platform and the associated paleo-sea cliff. The shoreline angle represents the maximum shoreline of a transgression and therefore a paleo-sea level. Origin: it is now widely thought that marine terraces are formed during the separated hailstones of interglacial stages correlated to marine oxygen isotopic stages. Tectonic and/or eustatic use of marine terrace sequence: the total displacement of the shoreline relative to the age of the associated interglacial stage allows calculation of a mean uplift rate or the calculation of eustatic level at a particular time if the uplift is known. In order to estimate vertical uplift, the eustatic position of the considered paleo-sea levels relative to the present one must be known as precisely as possible. Our chronology relies principally on relative dating based on geomorphologic criteria, but in all cases we associated the shoreline angle of the marine terraces with numerical ages. The best represented terrace worldwide is the one correlated to the last interglacial maximum. Age of Miss 5 years arbitrarily fixed to range from 130 to 116 Ka but is demonstrated to range from 134 to 113 Ka in Hawaii and Barbados with a peak from 128 to 116 Ka on tectonically stable coastlines. Older marine terraces well represented in worldwide sequences are those related to MIS 9 and 11. Compilations show that sea level was 3 plus or minus 3 meters higher during Miss 5e, MIS 9 and 11 than during the present one and a 1 plus or minus 1 m to the present one during MIS 7. Consequently, MIS 7 marine terraces are less pronounced and sometimes absent. When the elevations of these terraces are higher than the uncertainties in paleo-eustatic sea level mentioned for the Holocene and late Pleistocene, these uncertainties have no effect on overall interpretation. Sequence can also occur where the accumulation of ice sheets have depressed the land so that when the ice sheets melts the land readjusts with time, thus raising the height of the beach or sound in places where coast-seismic uplift occur. In the latter case, the terraces are not correlated with sea level hailstones even if coast-seismic terraces are known only for the Holocene. Other coastal quaternary morphologies registering uplift. Uplift can also be registered through tidal notch sequences. Notches are often portrayed as lying at sea level. However, notch types actually form a continuum from wave notches formed in quiet conditions at sea level to surf notches formed in more turbulent conditions and as much as 2 m above sea level. As stated above, there was at least one higher sea level during the Holocene, so that some notches may not contain a tectonic component in their formation. Worldwide occurrence: raised beaches are found in a wide variety of coast and geodynamical backgrounds such as subduction on the Pacific coast of South America, of North America, passive margin of the Atlantic coast of South America, collision context on the Pacific coast of Kamchatka, Papua New Guinea, New Zealand, Japan, passive margin of the South China Sea coast, on west-facing Atlantic coasts, such as Donegal Bay, County Cork and County Kerry in Ireland. Bute, Widemouth Bay, Crackington Haven, Tintagel, Paranporth and St Ives in Cornwall, the Vale of Glamorgan, Gower Peninsula, Pembrokeshire and Cardigan Bay in Wales, the Isle of Jura and Isle of Arran in Scotland, Finisterre in Brittany and Galicia in northern Spain and at Squally Point in Eatonville, Nova Scotia within the Cape Chignecto Provincial Park. See also: beach, beach ridge, isostasy, landform, maca, marine terrace, raised shorelines, terrace, wave-cut platform. References: 1 Johnson, M.E. and Libby, L.K., 1997. Global Review of Upper Pleistocene Rocky Shores, Tectonic Segregation, Substrate Variation and Biological Diversity. Journal of Coastal Research, 13, 2, 297-307. 2 James, N.P., Mountjoy, E.W. and Amura, A., 1971. An early Wisconsin reef terrace at Barbados, West Indies, and its climatic implications. Geological Society of America Bulletin, 82, 2011-2018. 3 Bull, W.B., 1985. Correlation of Flights of Global Marine Terraces. In, Morris or M. and Hack J., 15th Annual Geomorphology Symposium. Hemel Hempstead, State University of New York at Binghamton, pages 129-152. Forota, Y., 1986. Marine terraces as reference surfaces in late Quaternary tectonic studies, examples from the Pacific Rim. Royal Society of New Zealand, 24, 357-375. 5 Muse, DRAL, 1990. Age estimates and uplift rates for late Pleistocene marine terraces, Southern Oregon portion of the Cascadia Forearc. Journal of Geophysical Research, 95, B5, 6685-6688. 6 Padoja, K., Bourgeois, J., Pingina, T. and Higman, B., 2006. Does Kamchatka belong to North America? An extruding Wakutsk block suggested by coastal neotectonics of the Oznoi Peninsula, Kamchatka, Russia. Geology, 34, 353-356. 7 Padoja, K., Dumont, J.F., Lemov, M., Ortlieb, L., Collot, J.Y., Galeb, B., Auclair, M., Alvarez, B., Labrousse, B., 2006. Quaternary uplift of the Mantle Peninsula and La Plata Island and the subduction of the Carnegie Ridge, central coast of Ecuador. South American Journal of Earth Sciences, 22, 1-21. 8 Padoja, K., Ortlieb, L., Dumont, J.F., Lemov, J.F., Galeb, B., Auclair, M., Labrousse, B. 2006 Quaternary coastal uplift along the Talara Arcade from new marine terrace data. Marine Geology, 228-73-91. 9 Keikler, G.J. ALll, 2002 Last Interglacial Climates Quaternary Research, 58, 2-13. Tenembry, J. ALll, 1984. The Orbital Theory of Pleistocene Climate, Support from Revised Chronology of the Marine 1800 Record. In, A. Berger, J. Imbri, J. D. Hayes, G. Keitler and B. Saltzman, Milankovic and Climate. Reidel, Dordgt, pages 269-305. 11 Harty, P. J. and Kindler, P. 1995. Sea level housed and chronology from stable carbonate platforms. Journal of Coastal Research, 11, 3, 675-689. 12 Zazo, C., 1999. Interglacial sea levels. Quaternary International, 55, 101-113. 13 Rust, D. and Kershaw, S., 2000. Holocene tectonic uplift patterns in northeastern Sicily, evidence from marine notches in coastal outcrops. Marine Geology, 167, 105-126. External links, notes at NAST.